Here we are going to discuss adding and subtracting rational expressions. We have already discussed multiplying and dividing them, as well as finding their least common denominator. So now what we need to do is we need to add and subtract these rational expressions. Remember, with any fractions, for adding and subtracting, we must have a common denominator. So making sure that you get the least common denominator is going to be vital when we add and subtract rational expressions. So the steps for adding and subtracting rational expressions: first step is factor the denominators of each rational expression. So in other words, factor all the denominators. This way we can identify the LCD, the least common denominator, which is step 2. Rewrite each rational expression as an equivalent expression with the LCD as its denominator. Meaning, rewrite the fraction or the rational expression in terms of the least common denominator, multiplying numerator and denominator by what's missing. Then we add or subtract, whichever one it is, the numerators. The denominator stays the same, and that's going to be key. The denominator stays the same. It's still over that common denominator. After we've added and subtracted the numerators, we simplify those as much as possible. We may need to factor them, and then we simplify the entire rational expression into lowest terms. So let's look at an example. 4c over c plus 5 plus 20 over c plus 5. Now notice in this particular one, my denominators are actually already the same. So I'm going to end up with a c plus 5 on my denominator. My numerator, what I'm going to do is, since I didn't have to change anything, I'm just going to take 4c plus 20. Remember that we cannot combine these two terms because they're not common. One has a variable, one does not. So we cannot combine those. So that's as much as the adding as we can do. Now what we do is we look at possible factoring. Denominator is already factored. Numerator, I can take out a greatest common factor of 4. And that will leave me with a c plus 5 over a c plus 5. Now to simplify, remember I can cross out numerator for denominator. I cannot cross out at this point because they're not the same and they've got plus signs. I can only cross out factor for factor. I can't simplify the 20 with the 5, anything like that. At this point, because I have 4 times c plus 5 and a c plus 5, then I can simplify by marking those out, leaving me with a 4 over 1, or simply 4. Okay? Let's look at another example. D squared over d minus 1 minus 8d minus 7 over d minus 1. Now again, my denominators are already the same. So what I'm going to do is I'm going to keep my denominator, d minus 1, and I'm going to take the first one minus, here's where I have to be careful. I'm subtracting this entire numerator for the second one, so I need to put it in parentheses. That way, whenever I start simplifying, I distribute this minus sign in here, and I get d squared minus 8d plus 7 over d minus 1. Again, at this point, I want to simplify as much as possible. I cannot simplify d for d, anything like that at this point. What I have to do is I have to factor the numerator. So if I come over to the side, d squared minus 8d plus 7, factors that multiply to give me positive 7 are either going to be positive 1 and positive 7, or a negative 1 and a negative 7. That add up to a negative 8, it'll be the negative 1 and negative 7. So I get d minus 7 times a d minus 1. So I'm going to come down here, d minus 7, d minus 1. over my already common denominator of a d minus 1. Now that they are factored, now I can simplify d minus 1, leaving me with strictly a d minus 7 over 1, or just a d minus 7. Okay. Now, both of these already had the common denominator. Let's look at some that do not have common denominators to begin with, such as this one. We have 24 over m squared minus 4m minus 3m over 2m minus 8. So our first step is to factor the denominators. So I'm going to get 24 over, I can take out an m, and leaving me with an m minus 4, minus my 3m, and in this 2m minus 8, I can again factor out a 2, leaving me with an m minus 4. So we have our denominators factored. Now notice that the m minus 4s are the same, so I'm going to leave those, and I'm going to scoot over just a little bit. Now in the first one, I have an m, which is good. I don't have that m over here, so I'm going to multiply both numerator and denominator by that m. In the second one, I have a 2 that I don't have in the others, so I'm going to multiply numerator and denominator by a 2. So that gives me a 2m times an m minus 4 on my denominators. 24 times 2 is 48. 3m times m is 3m squared. Now I have common denominators. I can subtract the numerators, giving me 48 minus 3m squared over 2m times an m minus 4. Now again, especially since we have a square in the numerator, we need to factor. So I'm going to come over to the side and look at this 48 minus 3m squared. You've heard me talk before. I really want the m squared in the front, so I'll look at it as a negative 48 m squared plus a 48. Notice I left the signs for each individual one in the same place. For these, I can take out a greatest common factor of a negative 3, leaving me with an m squared minus 16. Let's see here. There we go. Minus 16. Now I still have an m squared, so I'm going to factor that. That is a difference of two squares. M squared minus 16 is the same thing as m minus 4 and m plus 4, bringing down my negative 3 in the front. So I now have negative 3, m minus 4, m plus 4 over 2m m minus 4. I'm going to cancel out 1 for 1, cancel out my m minus 4s. Now I cannot cancel out this m for this m because this m is attached to the 4. So my final answer is going to be a negative 3 times an m plus 4 over 2m. And I'm just going to leave it. I could distribute the numerator. Doesn't really matter. It's probably easiest to just go ahead and leave it. Okay, let's skip down and look at this one. P minus 3 over p squared plus 3p plus 2 plus p minus 1 over p squared minus 4. Notice both denominators have squares in them. So that's going to mean I've got to factor out both denominators. Okay, so if I look at p squared plus 3p plus 2. Factors of positive 2 that add up to give me positive 3 is going to be p plus 1 and a p plus 2. So I'll end up with p minus 3 over p plus 1, p plus 2, plus, now looking at the p squared minus 4, that's a difference of squares, which will give me p minus 2 times a p plus 2. So I'm going to end up with p minus 2 times p plus 2 on the denominator, and a p minus 1 on the numerator. Now looking for my common denominator. This one has a p plus 1. This one does not, which means I'm going to have to multiply numerator and denominator by p plus 1. Now looking at the first one versus the second one, this one has a p minus 2, so I'm going to have to multiply the first one by p minus 2. You'll notice I'm putting the p minus 3 and the p minus 1 in parentheses. That way I know to multiply that entire thing, which means to multiply it out, FOIL it out, and everything. So my common denominator is going to be a p plus 1 times a p plus 2 times a p minus 2. My numerator is going to be p minus 3 times a p minus 2 plus my p minus 1 times a p plus 1. And I'm going to go ahead and multiply the numerator out. I'm not going to multiply the denominator out. I'll multiply the numerator out. So I get p squared minus 3p minus 2p plus 6 plus p squared minus 1p plus 1p minus 1 all over p plus 1, p plus 2, p minus 2. I'm going to simplify the numerator, combining like terms. So that means my p squared plus a p squared is going to end up with a 2p squared. My 3p minus 2p is a negative 5p, minus 1p would be a negative 6p, plus 1p would give me a negative 5p. And then a 6 minus 1 gives me a negative 5 over p plus 1, p plus 2, p minus 2. Now since I have a p squared in the numerator, I'm going to come over to the side with 2p squared minus 5p minus 5 and try to factor this. Since I have a leading coefficient, it's 2 times a negative 5, so that means I want to multiply to get a negative 10 and add to give me a negative 5. Well, factors of negative 10 are negative 1, positive 10, negative 10, positive 1, negative 2, positive 5, or a negative 5, positive 2. These add up to a 9, this adds up to a negative 9, a 3, and a negative 3. None of these add up to a negative 5. This is as far as I can go. That is my final solution, because I cannot factor the numerator and cancel anything out. Okay, let's look at one more. This one has 3 rational expressions. So we're going to factor each denominator. So the first one is actually already factored, so I get 2 over c plus 2. The second one is actually already factored, 3 over c. And anytime I have a minus, I'm probably going to go ahead and make that a plus and move the minus up into the numerator. It makes it a little bit easier whenever I'm working with these. And then plus c plus 10. Now my denominator, c squared minus 4, is a difference of squares. So I'm going to end up with c plus, let me undo that, c plus 2, c minus 2. Okay. So whenever I look at this, these two have a c plus 2. This one does not. This one needs a c plus 2. This one has a c, the other two do not. So I'm going to multiply this one by a c and this one by a c and put a c down here. Now the c plus 2 is already here and all three of them have it. The c minus 2 I need. And I actually need the c minus 2 in both of these. So I need a c minus 2 and a c minus 2. So that gives me, on this first one, a 2c times a c minus 2. And right here, it doesn't really matter if I use the plus or minus, that 3 is negative. C plus 2, c minus 2. And then this one, I end up with plus a c times c plus 10. And I'm going to multiply these out. So here I'm going to distribute 2c in here. And I'm going to get 2c squared minus a 4c. This one I'm going to leave the minus 3 for now. And I'm going to multiply these two, giving me a c squared minus 2c plus 2c minus 4 plus, and I'm going to distribute the c in here, so that's going to be c squared plus 10c. I still have my same denominator, c times c plus 2 times c minus 2. I still have to distribute this negative 3 into this parentheses here. So that's going to give me a negative 3c squared plus 6c minus 6c plus 12. Everything else is going to come straight down. And my denominator is going to stay the same. Now then, I'm going to combine all my like terms, okay? So I have a 2c squared minus c squared, so that gives me a negative 1c squared, plus a c squared, so the c squareds actually cancel out. Then I'm going to look at my c's. I've got negative 4 plus 6, so that gives me a positive 2, minus 6 would give me a negative 4, plus 10 gives me a positive 6c, and then I have a plus 12. Still over c times c plus 2 times c minus 2. I'm going to see, can I factor the 6c plus 12 out? I can, because I can take a greatest common factor of a 6 out, leaving me with a c plus 2 over c plus 2, c minus 2. And then I'm going to simplify the c plus 2's. So that gives me 6 over c times c minus 2. Now I realize that is a lot of work and everything for one problem. The biggest thing is making sure that you get those denominators factored before you try to do anything, and then making sure that you get the common denominator. Okay? So try some adding and subtracting rational expressions, and if you have any questions, let me know.